ionic bonding. So which substance is having ionic bonding? How we can identify to be ionic bonding? What are the characteristics of ionic bond? Like it should have a high melting point, high boiling point. It should be soluble in water. Does not conduct electricity in solid. It can conduct electricity in molten. So which substance could be ionic? First thing, it should have a high melting and boiling point. So when we check, either G can be there, H can be there, or J can be there. Then the second part, it should be soluble in water. Ionic compounds are water soluble, so it cannot be G now. And it cannot be J, so we are left with only possible answer H. It can conduct, so the first answer is H. Then which substance in the table has a giant covalent structure? Giant covalent structure, it will have a high melting point, high boiling point. It does not dissolve in water. Normally, giant structure, except for graphite, does not conduct electricity in molten or aqueous. Except for graphite can conduct, but other giant structures cannot conduct for the macromolecular structure. So what could be a giant structure? Giant covalent structure from the table. High melting and H is already, H is already we selected already H, so we cannot, it cannot be, so we are left with J and G. But J is conducting in both. Giant structure normally does not conduct except for graphite. So that's why it is G is a correct answer. J is actually a metal, structure of a metal. Name a method you could use to separate a mixture of substance J with water. J is insoluble. I want to separate J from water. How I can separate J from water? Which technique can be used? The technique which we can use to separate the soluble substance, insoluble substance from water, that is filtration. Then name a method you could use to obtain a solid F from a mixture of substance F and water. So we want to obtain F from water, but it is very soluble. And what is the state of the F? The state of the F is liquid at room temperature. So we, like, it is a miscible liquid. So whenever we want to separate the miscible liquid, because F is liquid and water is also liquid, so whenever we want to separate miscible liquids, we use fractional distillation. On the basis of the boiling point, the two substances are separated from each other. Then describe how you could obtain a sample of substance H from a mixture of H and G. So if we have a mixture of H is combined with G and we want to separate them, this is G and H, one is soluble, one is insoluble. So first what we will do, because we want to obtain, G is insoluble, H is soluble, and we want to separate the solid sample H. So first what we will do, we will add water. Once we add water, the G will not dissolve, it will be insoluble and H will dissolve. So we'll add water, then we will filter. And at the last, we will evaporate the filtrate to obtain the substance H from the mixture. Because first, when we add water, so as a result of adding water to this, G, because it is insoluble, so we'll have G remain as insoluble and H will dissolve. When we filter, so G will left on the filter paper and H will be there, which passes through a filter paper as a filtrate. And how to obtain or how to get this H from the mixture from water? We can simply evaporate or use crystallization to obtain this H. The substance J is a metal. Describe how substance J is able to conduct electricity when in solid. So how metals are able to conduct electricity? Because metals have free electron. Metals have a giant lattice of a positive ion and the free electrons, and these electrons are free to move. So it has a lattice of positive ions and free electrons, and these electrons can flow through the structure or move through the structure. That's why it can conduct electricity in a solid state. Metal can exist as a solid, liquid, or a gas. The arrow shows some changes of the state. Name the change state represented on the diagram ABC. Use screen annotation to complete this. You can use screen annotation to complete this part. What is the change A? A solid turn to liquid. Change B when a solid turned to a gas. And change C when a gas turned into liquid. This one is the melting. B because a solid turned into a gas, or sublimation, and C is a gas turned to liquid, that is condensation. Explain why energy has to supply to turn liquid into a gas. So why we have to supply energy? So energy is basically needed to break the bonds between particles, or you can say molecules. Then the diagram represents same number of the particles in two different containers. Which container exert a higher pressure? The container E, because it's having a small volume. So there are more collisions. As a result, it will exert a high pressure. This question is related to organic chemistry. The petroleum is a mixture of a hydrocarbon. It is separated into useful fractions by fractional distillation. This can be done using a fractionating column as shown. What happened to petroleum at point X before it entered? So what we do to this petroleum, we vaporize or we heat, or we can say we boil the petroleum. So we now vaporize or evaporate or boiled or heated before it entered this column. State two ways the fraction O and L are different from each other. So how these fractions O and fraction L are different from each other? As we go down, there are more carbon atoms, and the boiling point and the melting point increases. The viscosity also increases, become more viscous, thick, color also become darker. So you can mention O will be darker, O will have more carbon atoms, O will have high boiling point or melting point. So O will have a high melting point or boiling point. Then most of the hydrocarbon obtained from a petroleum are alkanes. The alkanes are a homologous series of a saturated hydrocarbon with a journal formula CnH2n plus 2. Two characteristics other than having a journal formula of a member of a homologous series. So what are the characteristics of a homologous series? In a homologous series, they have the same similar chemical properties or same chemical properties, and physical properties gradually change. So they will have same chemical properties. Physical properties gradually changes or changes with a trend. or journal formula we cannot mention as it already mentioned, or each member of a homologous series differ by CH2. Then alkenes with a molecular formula C5H12 can exist as a number of structural isomers. We have to draw the two isomers of alkene. Remember, whenever you're drawing the isomer of alkene, as I mentioned, first you will make a straight chain and then make a branch. So one you will make a straight, and the other one, to draw an isomer, you will draw a branch. And remember, the branch should always be with the second, like not with the first. With the first carbon, if I attach, it is not refers to branch. So 5 carbon are there, 1, 2, 3, 4, 5. They are linked with single bond because it's an alkane. This will have 3 hydrogen, this will have 2 hydrogen. I will write the hydrogen H. And the other one will draw 4 in a straight chain and one of them as a branch, but don't put branch with the first one. Branch should always be started with the second, but don't put with the first one. So branch, and you can put it up or down. It does not make difference to the structure. So this will have 3. So when we put, this will have 3 hydrogens. This will have 2 hydrogen, 2 hydrogens, 2 hydrogens, and 3 hydrogen. And the other one will have 2 hydrogen, 3 hydrogen first, 1 hydrogen. Now, how you can check whether your structure is correct or no? You have to count the number of hydrogens. If it matches, like see, it is C5H12 for both cases, means these are the isomers. So to draw an isomers of alkane, first draw the straight chain and then draw the branched one. Alkanes, ethane has a structure as shown. When a mixture of a ethane and a chlorine are exposed to ultraviolet radiation, a substitution reaction occurs. Give one organic product. Look what happened. If we have ethane, it reacted with chlorine. Chlorine is Cl2. So what happened in a substitution reaction when atom or a group of atoms displaces the other? So one chlorine will enter and one hydrogen will leave. So what will be the product here? That one of the hydrogen is replaced by chlorine and plus HCl will be there. So we have to draw the organic product, or this is the organic product. So 2 carbon atoms. This will have 3. You can replace any of the hydrogen. It is not necessary that this will be replaced. You can replace with any. And there will be a chlorine. This is a chloroethane. So every time one of the hydrogen is replaced by one chlorine atom. Isoprene is naturally occurring hydrocarbon. Explain how the name isoprene suggests that it contains a double bond. So how it suggests it contains a double bond? Because in the name it is ending at, the name is ending at ENE. So it means that there is a double bond. Then a sample is there which contains 88.24% carbon and 11.76% hydrogen. We have to find the empirical formula. So how we can find the empirical formula? 3 steps we will follow. If you want the empirical formula, first, this is 88.24 and this one is 11.76. We divide by atomic mass. So atomic mass of a carbon is 12, whereas atomic mass of a hydrogen is 1. So it does not make difference. So 88.24 divided by 12, what's the answer? 88.24 divided by 12. So it will be 7.353. So 7.353, and this will remain same as 11.76. The second step, divide by smallest value. So 7.353 is the smallest value here. So we divide by 7.353 and this also 7.353. So when we divide this, one of the values 1 and one of the values 1.6. Now, we don't round off. We only, like example, if it is like 1.9, we say it is 2. But it is 1.6, so we cannot round off to 2. We have to now make a simplest whole ratio in a whole number. So I have to multiply with a certain number so that it will become a complete whole number. So if I multiply both of them by 2, it won't be a whole number. If I multiply by 3, but if I multiply both of them by 5, because one of the value is 1.6. So if I multiply both of them by 5, so this will be 5, and 1.6 into 5, this will be 8. So the empirical formula of this compound is C3H8. So the common mistake what students normally do, that they think like if it is 1.6, you will round off to 2. That is not the right way. You don't try to round off, you try to make the simplest ratio in a whole number. You don't try to change the ratio, because if you change 1 to 1.6 is totally different from 1 to 2. That's why we did not round it off. We just multiply with a certain number so that it will make a whole number. So how to do this? If I multiply both of them by 2, like example, say if you in exam you don't know which number I should multiply. So it's a simple rule is you can check with different numbers. If you multiply both of them by 2, so this will be 2, this will be 3.2. It is not the whole number. Then if you multiply both of them by 3, if you multiply both of them by 3, this will be 3 and this will be 4.8. So again, it is not a complete whole number. You want to multiply with a number which will convert the simplest ratio into a whole number. So if you multiply both of them by 4, so this will be 4, and 1.6 into 4, that is 6.4. So again, it is not a whole number. But when I multiply both of them by 5, so this will become 1, this will become 5 and this will become 8. So C5, not C3, C5 and H8 is the right answer. Then what else we need? Additional information to calculate the molecular formula. So molecular formula, the molecular formula is equals to empirical formula multiplied by N. So what we need, we have the empirical formula. What additional information we need? We need the value of N. And what is the value of N? The value of N is molecular mass divided by empirical mass. So we need molecular mass and empirical mass to get the molecular formula from empirical formula. In question 4, ammonia is made by reaction of a nitrogen with hydrogen in a Haber process. Write a chemical equation for formation of ammonia in Haber process. So when N2, the nitrogen, reacted with 3 moles of hydrogen, gives 2NH3. That's a reversible reaction. 1 mark is for correct reactant product. 1 mark is for balance equation. Name a raw material from where we obtain nitrogen. So nitrogen is from air, liquid air, and hydrogen is from hydrocarbons. State the temperature and the pressure used for this Haber process. So we use about 450 degrees centigrade, and the pressure is about 200 or 300 atm is used. So 450 degrees centigrade and 200 atmospheric pressure or 300 atm is used. High pressure is used. But in a contact process, we use only 2 to 3 atm. Ammonia is also made when ammonium carbonate decomposes. The reaction is reversible and can reach a position of equilibrium. The graph shows how the yield of ammonia at equilibrium changes with temperature. Look, ammonia is a product when we did it, the reaction is carried out at 100, and when the reaction is carried out at 300. So when the reaction is carried out at 300, we are getting more ammonia as compared to reaction carried out at 100. So what this gives an idea, what is the forward reaction, endothermic or exothermic? if we are getting more ammonia, if we are getting more product at high temperature. So which reaction is this? The forward reaction. So this gives an idea that the forward reaction is endothermic, because if you get more product and increasing in temperature gives more product, the forward reaction is endothermic. If the amount of ammonia was decreasing, when we increase the temperature, it means the forward reaction is exothermic. So what is meant by the term equilibrium in a reversible reaction? It's of 2 marks. So the definition of reversible reaction, the rate of forward equals to the backward reaction, and there is no change in concentration. But don't write in exam that the concentration of a reactant products are equal. That is not the right answer. You should mention no change in concentration instead of saying concentrations are equal. Using information from the graph, whether the reaction is endo or exo, so we can say the reaction is endothermic because produce more ammonia or more product at high temperature, or shift the equilibrium towards right hand side when we increase the temperature. State and explain effect of increasing the pressure on the yield of ammonia. What will be the effect of increasing a pressure? You can use the graph, or you can check the moles of a gas. In the reactant side, we have 0 moles of a gas. There is a mole of solid, but not for gas. We always check for gas. Here, this is a gas. Water is a gas. Carbon dioxide also mentioned as a gas. So 4 moles of a gas. So whenever we increase the pressure, where the equilibrium will shift, it will shift towards the side where number of the moles of gas are less. So what will be the effect if we increase the pressure? So the equilibrium, the yield of ammonia will decrease. And what is the reason for that? Because increase in pressure shift the equilibrium towards the side of less moles of gas. So in this example, it will shift backward, because in the backward you don't have any moles of a gas. As a result, it will reduce the yield of ammonia or amount of product. Yield refers to amount of product as well.